Hello again. Now we will start the chapter Force, Energy and Simple Machines. In this session, we will discuss forces. Now, forces are categorized in two broad categories. So, force is broadly of two types. The first is a contact force, and the other category is that of non-contact forces. Now, we have already studied forces, so I hope you remember that the contact forces, the three most commonly encountered forces are normal reaction, friction, and tension. So let's first once again briefly discuss all these forces. If you recall, we had studied that normal reaction is the force that is applied through contact, and normal always acts perpendicular to the contact surfaces, right? So if there are two blocks placed adjacent to each other and say you push this block, then the block A will exert some force on block B. Now this force that is exerted through contact is an example of normal reaction. And when the force is exerted, see, this is the contact surface. So the force that A exerts on B, and by Newton's third law, B will exert an equal and opposite reaction. Right. So the force that A exerts on B and the force that B exerts on A, both of them are perpendicular to the surface. And these two forces that we are talking about are nothing but the action and the reaction pair. So this is the force that A applied on B, and the reaction, which is equal and opposite, is the force that B applies on A. Right. So normal reaction is always perpendicular to the surface along which there is contact. Right. And normal, we had discussed, is always a pushing force. Normal never pulls. For example, when you keep your book on top of a table, the table supports the weight of the book by pushing it upwards, but that same table never attracts that book. Right. The next force is friction. Now, if you recall, we had discussed that friction comes into play whenever there is relative motion between two surfaces. So if there is relative motion, or if there is a tendency of relative motion between two bodies in contact, then they both exert a frictional force on each other. And the reason to exert frictional force is that the body does not like the other body to move with respect to itself when they are in contact. So let's take a simple example. Say you put a block on top of another block. Let's call this block A and this be block B. So as long as both of the blocks are stationary, there will be no force of friction. Now, if both of these blocks were kept on a cart and this cart was moving with a uniform velocity, that is, maintaining its speed and direction. So if there was such a situation that this cart is moving with a uniform velocity and these two blocks are placed on this cart, then once again we would see there will be no force of friction. The force of friction will appear only if A tries to move with respect to B. That is, A tries to get ahead of B, or if for some reason A is getting lagged behind. So only when A moves with respect to B, we will see a frictional force. And Just as we saw that normal is perpendicular to contact, similarly, frictional force is always along the contact. So, as we had discussed, if this is the contact surface, then normal will act perpendicular to it, and if there is any friction, it will act along the surface. Right? Like in case of these two blocks, if at all there is any frictional force, then that force will either be forward or backwards. Right? So friction tries to oppose relative motion, and it always acts along the surface. The final force is tension. Now tension acts whenever there is a tendency for change in structure. So whenever there is change in structure, tension acts. Now, this change in structure could actually be there, or there could be a tendency for the change in structure. For example, if you have two blocks tied through an inextensible string, and inextensible means that the length of the string can never change. Now, if you try to move the block B towards right, then what will happen? Block A will also move. And why does it move? Because the string applies some force on A. So why is this force generated? Because when B moves, there is a tendency for a change in length. And this tendency for change in length generates a force which is called tension. The second property of tension is that it is always a pulling force. Just as we saw that normal is always a pushing force, tension is always a pulling force. The simplest example is that you can pull something using a rope, but you can never push it using a rope. Right? So tension appears whenever there is a change or there is a tendency to change in structure. And this force is always a pulling force. Right? Now, a slight exception in this is when we talk about springs. When we talk about springs, the force that the springs exert is also called tension. Now, in case of spring, there is always an actual change in length as opposed to the case of the inextensible string. So, in springs, there is always an actual change in length. So, if you extend the spring, if you extend its length, then it will try to pull itself back. Now this is the nature of tension. There is a change in length and it tries to restore it. But in case of springs, if you compress the spring, so if this is the normal length and if you try to compress it to a smaller length, then it will try to push outwards. In this case, again, we call it tension because the force is generated due to change in structure. But it is only restricted to springs. In case of threads or strings, so in case of threads and strings, we only see a pulling force, right? So these three forces together are example of contact force. Now let's talk about non-contact forces. The first thing that comes to mind is gravitational force. Now we have already discussed this in the chapter of gravity, that any mass attracts every other mass with a force which is given by the expression Gm1m2 by r square, where m1 and m2 are the masses of the two bodies and r is the distance between them. So gravitational force is the force that any mass exerts due to its own mass. Right. The second thing we know about gravity is that gravity acts through a distance. For example, even when a ball is in the air, the earth pulls it. Right? It need not be lying on the floor for it to have any weight or any pull from the earth. Even when it is in the air, it is pulled towards the earth. This is why gravitational force is a non-contact force. Right. Also, we saw that for any body on earth, we can write its weight, which is the force which earth exerts. So weight of the body is the force with which earth pulls that body. So the weight of the body can be written as mass times the acceleration due to gravity on the surface of earth. Right. So that is another way to measure weight. For example, if you have a 10 kg body and say I tell you that acceleration due to gravity is 10, then this 10 kg body has a mass or a weight, of 100 Newton. So a 10 kg body has a weight of 100 Newton. Right. What other forces can you think about? We have just discussed electrostatic force and magnetic force. So electrostatic force and magnetic force are both examples of non-contact forces. Right. So in electrostatic forces, we discussed that a charge Q, when placed at a distance from another charge Q dash, if the separation is R, then the force between them is given by KQQ dash by R square. Right. And magnetic force we know is the force between two magnets when placed close to each other. This is also the force that would be experienced by a moving charge. But the critical thing that we are focusing on here is that these forces are exerted from a distance. So they are non-contact forces. So whenever a force is exerted through a contact, it is a contact force, and whenever it acts from a distance, the force is a non-contact force. Right. Now, if you recall, we had also studied that there are only 4 fundamental forces. The first is electromagnetic force. The first is the electromagnetic force, then there is gravitational force, then there is weak force, and then there is strong force. Now, we have already listed down at least 6 forces, but none of them matches this category. So let's think about it. Let's think about the normal force. How does a body push another body? Now, this happens when, say, this block is in contact with this block. So the atoms of this block are now very close to each other. If you try to push them further, the repulsion between them is the reason why this block is pushed away. And the same force is exerted on the block A. So the normal force that is being exerted gets exerted due to electrostatic repulsion. So we could say that normal reaction is part of electromagnetic force. So normal reaction is actually an electromagnetic force because it gets exerted due to repulsion between atoms when they are pushed too close to each other. Right. The second force is friction. Once again, why does one body exert friction on another body? Now, when they are very close to each other, there is some interaction between them. which causes a kind of attraction. So when it moves further away, it tries to pull it back. So once again, this force has something to do with charges. Now the exact nature of this is not important right now. What our focus is that this force is generated due to charges. So the frictional force is also an example of electromagnetic force. What about tension then? Tension occurs whenever there is a change in structure. Now what defines that structure? I hope you're studying in chemistry that everything has a structure. For example, an H2O molecule might look something like this. But there are two hydrogens and one oxygen. Now what dictates the shape of this H2O molecule? It is the interaction of charges. So whenever you change this shape, there will be some forces which will force it to come back to the configuration, which is the equilibrium configuration. So whenever that equilibrium is disturbed, some electromagnetic forces will act and they will try to restore the shape. So this restoring force that is generated is also electromagnetic in nature, and hence tension is also an electromagnetic force. Right. Coming to gravitational force, we see that it is directly a fundamental force and hence no explanation is needed in that. Now what about magnetic force? The electrostatic force and the magnetic force we can clearly see are clubbed together as electromagnetic force. Now, the reason why we have clubbed these two together is slightly beyond the scope of our discussion. But the simplest way to explain this is that a stationary charge only exerts electrostatic force. But as soon as it starts to move, it exerts both electrostatic and magnetic force. So that is why the two have been clubbed together as a single fundamental force. Right. And if you recall, we had discussed that last two forces are effective only at very short range, which is of the order of 10 raised to power minus 15 meters. This distance is very close to the radius of a nucleus. So these forces are only effective inside nucleus. So for any distance which is more than the nucleus of an atom, these forces are not significant. Right. So with this, we come to the end of this session. So in this session, we discussed forces. We saw how they are categorized as contact and non-contact forces. And we saw how most of the forces that we see are basically electromagnetic forces. Right. In the next session, we will discuss energy. Thank you.